Autism. What is it? Why are diagnoses rising? And what is there still left to know? Today, we are with Dr. Adam Roberts from the Department of Psychology to help make it make sense. Let's start with the basics. What is autism and how has the definition changed over time?
Well, I'm not a clinical psychologist, so you have to forgive me if I don't have everything perfect, but it's a developmental disorder characterized by problems with social communication, social interactions, and also with repetitive behaviors or kind of activities or ideas. And so I work with animals, and so but we can see with animal models of any developmental disorders, particularly autism, we can see the same thing. We can see problems with social communication, social behaviors, and repetitive behaviors with animals. And the definition of autism will always change because humans are in charge of this behavioral definition.
Mhm.
So a lot of smart clinical psychologists got together in the 50s and they came up with this diagnostic manual. And from that manual, they start to characterize certain sets of behaviors. And in this case, in the 1950s, they called this autism. And so over, the course of 75 years, it's that definition is getting better and better and better. We're getting a better model and a better understanding of how to put things together. And so it always changes. But even at that beginning time, they captured that social part and I believe the repetitive part of that diagnosis. So it's been remarkably stable, if you're forgiving with the words.
So people can use animals to understand this neurological characteristic?
It depends upon the type. So when there's a strong genetic or biological cause of a human disorder, whether it be a psychological disorder or a neurological disorder, then if you recapitulate that same cause in an animal, then you often always get the same behavioral or neurophysiological output. And so humans and animals, we're molecularly very similar. And so we work the same. And so we can produce the same disorder-like or type from similar molecular changes.
And so you are studying this how and in what animal?
Yeah, so we're using zebrafish, which are vertebrate like humans, and a lot of genetic similarities. And so you can look at it two ways. You can use genes that are highly associated with autism, and you can delete or mutate those genes in zebrafish, and then look to see if you see some of the same behaviors. I'm more interested in the environmental causes of autism spectrum disorder. So in this case, we're exposing the zebrafish to certain toxins. And I'm not really interested in connecting those toxins to autism spectrum disorder, but I'm actually interested in what are the cellular molecular causes of behavioral changes. Because if we can kind of flip the script, if we can understand what are the mechanisms by which we get developmental disorders, then we can start to say, instead of doing what we're doing now, which is very ridiculous, we're saying, is BPA dangerous? Oh, it is. Take it off the market.
Yes.
We'll just replace it with BPS, which is probably as dangerous or more dangerous. And so now what we should do is we should start to create animal models where we can create little sentinels. So in this case, we're trying to create little zebrafish when exposed to a toxin. If that initiates a certain pathophysiology, so kind of the neural systems aren't working properly, we can get a fluorescence change in their little brains. And so if that brain is glowing green, then whatever you put in that water is not good. So we can start to say, is this safe before we put it in the environment?
Yeah.
But we have so many things that we know are dangerous that we're putting in the environment. There's a little hope.
So you're telling it, you're able to determine the environmental, that there is an impact in the environment by doing what, like scans of the brains, or you're looking at changes in the behavior? What are you doing?
You can do it lots of different ways. You could provide a toxin, and if you see a change in behavior, that would be indicative of a neural circuit change. But you can also you can genetically manipulate these animals so that when something's going wrong at a molecular level, that'll initiate a gene to be transcribed and translated into a fluorescent protein. Essentially saying, if this bad thing is happening within your cells, that cell will fluoresce. And if you're fluorescing, that's not good. And so that's, we need to change the way we think from saying something is dangerous, let's get rid of it, to saying, is it dangerous before we put it out there? And so by creating these fluorescent animals, we can do that. We can say, hey, this is causing problems with the zebrafish. And I guarantee you, if it's causing problems with the zebrafish, it will cause problems with the human. And so it just must be true.
Yeah. So a recent CDC report determined that 1 in 31 8-year-olds in 2022 had autism spectrum disorder. This was 5 times as many as in the year 2000. Why is the number climbing so fast? Any thoughts?
Well, most people will hand wave this, but I won't. And so what people are going to say is like, well, changes in diagnosis could account for that. And they're going to say changes in culture. So how one views other people might cause us to categorize people differently. So culture changes all the time. That's all true. And that could account for most of this. But we know now that there are environmental causes of autism spectrum disorder. I think it's a fair thing to say.
Yeah.
Now, what percentage, how much, when, why, what level of toxin causes a problem? These questions are all left to be determined. But there's no question that our environment is becoming more problematic. And so for having more pesticides, more air pollution, more toxins in the environment, it stands to reason we're going to have more developmental disorders and more developmental problems. So I can safely say that some percentage of this increase must be to environmental toxins. Now, we also are having an aging population, which as we age, our stem cells for sperm and egg are epigenetically modified in a way that would make us more prone to having a child with autism. So again, that's an environmental factor as well. But the aging population in combination with a more toxic, if you will, environment will account for some percentage of this increase in autism.
Is that debatable? Would everybody agree with you?
Well, I think most scientists would agree with that statement.
Yeah. Is there anything besides changes in how we diagnose and environmental factors that scientists argue may be causing the increase in diagnoses?
Yeah, I think if you lump aging population with environmental toxins and then you say diagnosis and potentially cultural views on things, I can't imagine anything else that could do it. So from that perspective, I think that covers everything that I can think of.
And vaccines, would those go into environmental factors? Or let's talk about that.
Yeah, vaccines could not be the cause of autism for 2 pretty important reasons. One is, I think there's incredible amounts of evidence saying that autism forms prenatally, so in the womb. And so that in utero environment, that's what we're concerned about. What a woman is being exposed to while pregnant, right? Those are the things that's when autism forms. In every animal model and every correlation with humans is prenatal, not postnatal. And so vaccines occur postnatally. We think autism forms, even though we don't see the behavioral outputs of autism until later. Everybody thinks it forms prenatally. Finally, we've got lots of studies now that show, major studies that show that the unvaccinated populations, so people that have not had vaccinations and people that have had vaccinations, have no statistical differences in rates of autism. So if vaccines were causing autism, unvaccinated people should have much lower rates of autism, and they just don't. Also, ideas like mercury in the vaccinations are causing the autism. After we removed mercury from the vaccines, autism rates went up. And so a lot of really good studies looking at this just say that it's highly unlikely, if not impossible, for vaccines to cause autism.
Great, thank you. What is considered settled science about autism, and what are people still debating and trying to figure out?
Yeah, so we know that there are certain genes that are highly related to autism. So I've seen estimates of 15 to 30% of autism is due to genetics. What that means is, in some of these, like SHANK3, are highly related. So if you were to inherit the SHANK3 mutation, you've got like a 70, 80% chance of having autism. And so that's a strong genetic cause in that case. So now it could be, that's an inherited gene. You can also have what are called de novo mutations, meaning the parents don't have the gene, but in either the sperm or the egg stem cell, or very early in development, a mutation forms, and then autism comes from that gene. So we know now that some forms of autism have a genetic cause. Now, that's 15 to 30. What about that? I think the big questions now is, what are the mechanisms by which autism forms? A lot of people are really interested in epigenetics. And all epigenetics changes mean is the DNA comes in this chromatin. And it's your DNA, and it all wraps up. And in order for that gene to be changed to an mRNA and then eventually to a protein, that gene, how wound or unwound that DNA is, will determine what proteins are made. And the proteins are what causes our brain to work. And so what are the environmental and the mechanistic causes of autism? So would be what we're really looking at. I think those are the real interesting questions and the unsettled science. And I think the other things that are fairly well settled, autism probably forms prenatally, so in the womb, and that vaccinations have nothing to do with autism.
Health Secretary RFK, what hypothesis is he interested in pursuing?
Well, recently he said that, and I think I'll quote, a massive testing and research effort, and that's, will be used to determine the cause of autism and, try to eliminate those exposures. And so it's kind of a laudable goal, but it's not how things work. So I'll give you one great question in science. What happened 4 billion years ago that allowed life to first form, right? We don't know. Now we have lots of great ideas. We know a plasma membrane must have formed. We have all theories on how first cells could exist. But if I were to come out and say, well, scientists, figure this out in 5 months. Well, that's not how answers occur. You can't just declare in 5 months we're going to get an answer.
Right.
And so science doesn't work that way. Now, what he could mean by that is we're going to take the best evidence that we have right now and come up with the most likely causes for these increases in autism, and then try to eliminate those potential causes. If that's what he means, you might not need 5 months to do this. The evidence is already out there. That would be an important thing to do. I think what he would discover, or will discover, is vaccinations do not cause autism. And in fact, vaccinations protect us from so many different things. But what he will discover, that a lot of these pollutants that we're putting into our environment, a lot of the things that that we've recently weakened the EPA, where I think just yesterday, they're allowing coal plants to release more pollutants into the environment. I think what Kennedy will come to conclusion is we have to stop these changes that the Trump administration are doing in order to protect people. And so, hopefully he'll come to that conclusion, and hopefully we can start to eliminate some of these highly correlated and therefore likely causes of autism.
Let's turn to your work. What are the major things you're asking, and how are you answering those questions?
Yeah, so I'm interested in how environmental toxins change the neural circuits, how it changes neural development and neural circuitry. And so we take known toxins and then we apply that to our animal model, which is the zebrafish larvae. And then we look to see what are the cellular mechanism, what are the pathophysiology, what is going wrong with the neural circuits after exposure to these toxins. And from that, we can start to understand. And so then there's two lines. One is to create sentinels to detect this dysfunction or pathophysiology. And the other is to say, hey, what can we give a pregnant mom that might alleviate some of these negative things, even though we have not given a perfect or great environment for our pregnant women in this country or in the world, really. But what can we do to mitigate? And folic acid and other things are great things that can do that. But what are some of the other things that could maybe hopefully create a more healthy in utero environment?
Oh, that's great. What toxins are you exposing the zebrafish to? What are you studying?
Yeah, we're really interested in bisphenol A, so BPA, because it's a ubiquitous toxin. And there are BPA-free things that have been replaced with other similar compounds, but they're probably going to work the same at a cellular level or very similarly. So we're just using BPA to try to understand that pathophysiology.
Why do you study BPAs? Have we seen an increase in this toxin in the environment?
Well, BPA it's involved in a lot of food products like soups and all that. You'll find it in cans of soup. It's kind of a ubiquitous toxin. It's involved with plastics and things. So it's on your receipts and some of your receipts anyways. And so it's a ubiquitous toxin. So it's important to study. And so its ubiquity is why.
Yeah, great. Outside of autism, do you have any other research interests?
Yeah, so I'm always been interested in synaptic plasticity and memory. So that's what got me into this. So when I was a psych student, I heard a talk about snail memory. And a Nobel Prize was actually given away for snail memory, believe it or not. And so it was just amazing to understand that tiny little changes in synapses, the connection between two neurons, that little change can cause a behavioral change. And I loved it because this is truth. This is where it's going. At the time, as a psych major, I was doing a lot of handing sheets of paper to undergraduates and then correlating two things they say. And it's not that there's not a truth there. It's just such a derived truth. what really you want to understand is what's happening in that human brain. But we're measuring a correlation of a correlation of a correlation when we look at this kind of written kind of thing. Now, it's the only way to answer certain questions with humans. But the snail memory really captured me in that is a truth. Those changes will cause that, and we can prove it. And so that's what got me into this. And that's more or less what I'm doing now. How are these cellular changes causing development to be different? And so it's the same question overall these years.
Yeah. And you were, that was when you were an undergrad. You were a psych undergrad?
And I did a master's in experimental psych. And so after that, I moved to my PhD in cell molecular physiology.
Yeah. So that's kind of the importance of, you went to a random talk and you heard something that changed your life.
That's it. Yeah. I knew after that talk that I needed to do neuroscience.
Yeah. Amazing. What about teaching? Did you know you were going to love teaching, or is that something you learned when you were here?
I was terrified of it. So, I mean, so my first class was at UCLA. It was 300 some people, and I have no idea what I'm doing. And it was terrifying. I'm sure they had a bad class, and I'm sorry to that 2010 class. But it took a lot of time, and I was teaching actually at a community college. And a dean pulled me aside, and she didn't say I was awful, but she nicely said I was awful, and showed me how to be better. And she explained how to interact, and that if you're talking, they're not learning, how to ask questions, how to interact, how to help them learn this material instead of just saying words in front of them. And so I probably wasn't good after that, but now I knew how to get there. And so over time, you just get better.
What do you most hope your students get out of your classes besides the content?
Yeah, I think unless they go on to be a neuroscientist, I think the content is the least important thing. It's the ability to think. Now, the content's the backdrop by which we help them learn to think.
Yes.
But the only way, a lot of things are kind of emergent properties. You can't really see or understand their growth until you talk to them. So if you take them through complex material, and you start with something as simple as, what is an ion? An atom that has gained or lost an electron. Well, that seems pretty hard to understand, or pretty easy to understand. But that concept will build with thousands of other concepts, and they'll be able to tell you why in the brain you're hungry, or where is where are the synaptic changes that underlie fear, and how do we know that's true? And so just watch them after a semester talk about what they can do. And you will see what they've learned to do. They've learned to think differently and think more complexly. The other thing they get from this is they're all lost when I start talking. So these concepts you can't learn the first time you hear them. Unless you've already had neuroscience courses, there's no way. So they learn to be okay to be confused. And they learn that if they just work and they just fight, they can actually learn really complicated things. And I think that's going to be really valuable for them, to be able to go into a situation where they know nothing and they're overwhelmed and know, well, last time I did this and I got there. They can all get there. Something like that.
Yeah. Wonderful. You're reminding me of, after I'd been teaching for a few years, I went to visit my brother. He was a religious studies major who decided later to be a doctor, right? So he was in this post-bac program.
Yeah. Those are tough.
Yeah. So I went to visit him, and he was like taking a chemistry class, and I sat in with him.
Brutal. Yeah.
And I had been so used to, for years, being knowing history, and being in that moment where I was like listening to something about chemistry, I was terrified, and I did commit to myself. I don't know how good I've been that I would try to continue to put myself in these difficult intellectual situations, because I think it's not it's easy to get comfortable intellectually. So I love what you're saying about the power of learning how to stick out that initial fear, and that it will go away.
Yeah.